Alright, so we're going to be doing store now. And the idea behind store is that we're going to get an address in MAR. That look like X4000. Value in MDR. That look like 5 or something. And then we turn both these on. Going to go into memory. Going to find our X4000. It's probably 4001. 3FFF. Yeah, it's going to place that 5 right into that 4000 slot. And if you don't know what it does by heart, we did give you this LC3 instructions detail sheet, which has if you just want a summary of what it does. There's this operation one-liner. There's also more specific description. Looking at this operation one-liner, it looks like we want to get, this is the address. So we're going to be wanting to get MAR and store it. PC plus PC offset 9. Then what's the data we want to store? It looks like we want to set it equal to SR. So we get MDR equal to SR. So PC offset 9, notice it's actually contained within the instruction. So it's going to be in the IR. So I need to somehow add the PC and the 9 bits in the IR together. And you can do a lot of experimentation, a lot of investigation, but and eventually you might come up with a path that we can get our PC around this little detour here into our adder 1 mux and get the offset bits. And which sign extender we need? Well, we're only going to want the 9 bits. So the bits from 0 to 8 is going to sum up to 9 bits. And to get that through our adder 2 mux, we'll successfully add them together. And here you realize to go right, it's actually a dead end, because you'll get stuck in the PC. And you don't want to turn load PC on because that's going to override your PC with some value you don't want it to be. So the correct answer is I should go left. And turn Marmux 1 here. And then from here we can get into MAR. So basically we can start from here. Start with this part, so we get our PC into our adder 1 mux, and notice you gotta turn this to 0. Oh, where is that? Turn that to 0 already, actually. And then want to get our IR. Want to accept this 0 to 8. So our address 2 mux should be 1 0. And now these have been added together. I go left. Marmux, and you like want to pick 1. There's Marmux, click there. And we're going to block this tri-state buffer, so we're going to turn that to gate Marmux. From there, all over the bus, and we want to accept it in MAR. And that completes our step. Return everything to 0. And we can't do anything more in our clock cycle because the next thing we're going to do is we need to turn MDR to SR. But in order to do that, we're also going to need to use the bus again. And we can't have 2 things in the bus. So we're going to need to do another clock cycle. How can I get the SR into MDR? There might be multiple ways to do it actually, but I think the simplest way is just passing it right through the ALU. Like that. And this might take some time to come up with, so I'm just giving you all the answer because I'm trying to make this video as short as possible, but don't worry if it takes you time to come up with the correct path. You're going to find a lot of dead ends in this homework, but it's kind of like a maze, honestly. And then you got to control like the train track levers with these muxes and stuff. Anyway, though, so what we can do is we'll set ALU to 1-1, just pass. And we'll turn gate ALU on. I'll do it live, so you know, see the progression. So far, I've done this. We turn ALU on to pass. Our passing A. We're stuck at this gate ALU. I'm going to turn gate ALU on. Okay. Now I guess on the bus, it's all over, but we really only care about this section. We'll turn LD to MDR on. And I think that's actually it. So from then on, we turn everything to zeros. And in the last clock cycle, it's kind of a weird clock cycle, but now we can finally turn memory enable and memory write enable on. So basically, lock in this address and lock in this data, and then replace the data at the address. So actually, everything turns off except for these two. So hopefully that helps. And we actually made some custom instructions for y'all. This is actually a TA made instruction. This isn't a real thing, but it's still a similar process to the other instructions. So, yep, hopefully this helps. Thanks for watching.